Welcome to Lesson 8C2. Here are our learning targets for this lesson. Make sure these are written clearly in your notes. The first learning target is that you should, at the end of this lesson, be able to find the number of terms in an arithmetic sequence or series. And second, we're going to find the sum of a series when the number of terms is not given to us. So let's get started. So there are many ways we could be asked to find the number of terms, so we're going to explore those different ways. So in this case, I'm going to give you the last term, which has a value of 580. I'm going to give you the first term, which has a value of 30. And I'm going to give you the common difference, which has a value of 11. So last lesson we learned that there were three different formulas we could use. Two were summation and one was the last term. Since I don't know the sum and I don't know the number of terms, I can't use the summation formula. So that forces me to use this last term formula. And if you'll remember, that last term formula is the last term equals the first term plus the common difference times the quantity number of terms minus 1. So basically, we're going to just plug in the values we know for each variable. So the last term has a value of 580. The first term has a value of 30. The common difference has a value of 11. And I don't know n because that's what I'm going to find. So now all we have to do is solve for the number of terms, which is our goal. So I'm going to start by using PEMDAS backwards. If your first instinct was to distribute, that's fine. It just adds a couple of extra steps. So I'm going to solve this in the more efficient way. Alright, so I'm going to deduct 30 from each side, because we're following PEMDAS backwards, which means that we should do any addition or subtraction first. Okay. Next, I'm going to divide by 11 on both sides, and that gives me a value of 50 equals n minus 1. And my last step is to add 1 to both sides. Okay, so that gives me a value of n equals 51. What this means is there are 51 terms in this sequence. So if I wanted to, I could say u sub 51, because this is our last term, equals 580. Not too bad, right? Alright, so there might be an instance in which I am given a series of terms, maybe like the first 4 terms. I don't know the last term, but I'm given the sum. So how would we find the number of terms there? So let me show you. Here we have the first 4 terms in a sequence. And again, you should be able to say that, well, I know that this is a series, right? Because why? Well, this is not a sequence because I have addition signs I have addition signs separating my terms, so that tells me that it is indeed a series. Okay, if it was just the numbers with commas, then it's a sequence. So, just a reminder of that subtle difference. So let me give you the sum. It's 91,047. Okay, so the first thing that I notice is I have our starting value. So this is A, is negative 99. I have the sum of some number of terms, S sub n, negative 91,047. And I can find D because I have the first 4 terms. So if I'm looking here, what I'm going to notice is it goes down by 21. It goes down by another 21. It goes down by another 21. Well, consistent decay or consistent growth means that this is arithmetic, which we knew, but just as a reminder, that's what it means. So that means our common difference is negative 21. Alright, so let's go ahead and look at the summation equations or summation formulas we learned in our last lesson. So we had this one. So the sum of some number of terms, that's n, equals half times the number of terms times quantity first term value plus the value of the last term. Well, we don't know the last term, so this one is not going to work this time. So we had the other one, which is a little longer, but combines the last term formula with this formula. So we end up with half n times quantity 2a plus the common difference times quantity n minus 1. Well, we know a, we know our sum, and we know d. So the only variable that we don't know is n, and that's what we're trying to find anyway. So this is the equation for s. Alright, so I'm going to find s sub n. Oh, I'm not going to find s sub n because I know s sub n. So I'm going to go ahead and put negative 91,047 in for s sub n. That equals half times n, which I don't know. So I'm leaving it as n. 2 times, I do know that a is negative 99 because that's my starting value, my first term's value. My common difference here is negative 21, okay, times quantity n minus 1. I don't know n, so it stays like that. Alright, so let's go ahead, and before I even do any simplification, I know I want to get rid of that fraction by multiplying this whole equation by 2. So when I do that, I get a value of negative 182,094. Okay, right, because I multiplied this by 2. And then I multiplied this whole term by 2. So it's all multiplied together. That only multiplies one of these things by 2. And I'm going to multiply half by 2. Okay, so half times 2 is 1. That gets rid of my term. And now I'm going to start simplifying. So 2 times negative 99 is negative 198. Negative 21 times n is negative 21n. And negative 21 times negative 1 is positive 21. Okay, I'm going to simplify even further. I'm going to combine like terms within the parentheses to get negative 177 minus 21n. Oops, I'm sorry, plus, yeah, minus 21n. Yes, that's correct. Alright, and now I'm going to distribute my n to both of these terms. Okay, so I end up with negative 182,094 equals negative 177n minus 21n squared. You might be thinking, well, I now have a quadratic, and that is true. So I don't know about you, but I am not so interested in factoring something that looks like this. So I'm going to use the quadratic formula, but to factor or use the quadratic formula, I have to have all the terms on one side, and I kind of prefer positive numbers, so I'm going to move both of these to the other side using addition. So add both of those to the other side, and I get 21n squared plus 177n minus 182,094, and that equals 0. So I'm going to pop this into the quadratic formula, and knowing that I'm going to get out two values. The only value that's positive, well, the only value that's going to work has to be positive, because I can't have a negative number of terms. So you're going to exclude the one that's negative. Okay. So you could do this straight into your calculator, making sure that you use parentheses correctly so you get the right answer. My pen is just not working so well today, and I'm really writing crooked. Okay. So when I put this into my calculator, I'm going to get two values. The one I want is the one that tells me that n is 89. Right? The other one's negative. I don't really want that, so I'm done. So I have 89 terms in this series, or in this sequence. Okay? So that means that I could find the last term if I wanted to, but I don't need to because it doesn't ask me to. But I could because I know that there's 89 values, so my last term would be u sub 89. Alright, finally, the last instance in which we might be able to find the number of terms is if we're given the sum of 203,424. Okay, we're given the starting value, which is 3, and we're given the last term, which is 6,360. So in this case, I know my last term, and I know my first term, and I know the sum. Well, we went over the two summation equations in the prior example, so since I don't know the common difference, I can't use the formula I used for the last problem. I can use the shorter one, that looks like this. The sum of some number of terms equals half times the number of terms times the quantity's starting value plus ending value. Much easier when you know the last term. Okay, and this is not going to turn quadratic, so that's kind of an extra bonus of knowing the last term. So I'm going to say, oh, I did the same thing again. I know the sum of some number of terms, so I'm going to substitute 203,424 in, equals half n, which I don't know. I know that a is -3, and I know L is 6,360. So I'm going to do the same thing I did last time, and I'm going to multiply this whole thing by 2 just to get rid of my fraction, and I end up with 406,848. That equals n. Okay, right, because I still have n. Multiplied n over if I wanted to, it doesn't matter, equals 6,357. So I combine these terms. Okay, so now I am going to divide here. Divide by 6,357, and I get an n value of 64. So I have 64 terms in this series. Now remember how I said earlier that if you wanted to, multiply by 2 or 2 over n, if you wanted to move n over, you would get the same answer. It's just a little different process.